These are the notes for section 2.4, writing equations of lines. Now in this section we're going to look at another kind of equation for a line called point-slope form. So let's begin by writing that out, and then we'll come back to it here in a little bit. Point-slope form looks this way. Y minus y sub 1 equals the slope, which is m, times the quantity x minus x sub 1. In point-slope form, the m is the slope, just like slope-intercept form. And the ordered pair, x1 comma y1, is a point on the line. And the x and the y are just your variables. So that's what each part of that equation is. So when we write an equation of a line, there are really two forms we can do that with. The first one is slope-intercept form. That's the one we're most familiar with. Of course, slope-intercept form looks like y equals mx plus b. If I know what the slope is, the m, and I know what the y-intercept is, the b, I can just plug those numbers in to that model and have my equation. On the other hand, sometimes we might know a slope, but we don't have the y-intercept. If we do have another point, however, we'll call that point x1, y1, we can still write the equation of this line. We just have to use point-slope form, which says y minus y1 equals m times x minus x1. And the third situation, if I know 2 points the line goes through, well, we know how to calculate the slope. So first, we're going to use the slope formula to find the slope m. Then I can use the point slope form, once again, to write the equation of the line. Now in this situation, I actually have 2 points. I'm only going to use one of the two. It doesn't matter which one you pick, but you're going to plug that into the point-slope form to find your equation. So let's take a look at example 1 and see if we can write the equation of a line for a graph that is shown. So from this graph, we want to try to identify a couple of things. First of all, I can identify the slope by locating 2 points that are on this line. One point that we know for sure is right here, the point 0, 1. That's also the y-intercept. Now, if I follow this line, if we go down and to the right here, it appears that another point the line goes through is this one right here. So the slope of this line then, my rise, actually it goes down, 1, 2, 3. So that's negative 3 for the top number of my slope. And then I have to go to the right, 1, 2. That would be a positive 2 for the bottom number. So the slope of this line is negative 3/2. Now, also, like we said a minute ago, the y-intercept is easy to see here. It's the point 0, 1, which means the b in this problem is positive 1. So if I know the slope and the y-intercept, I can take y equals mx plus b. I can substitute, in this case, negative 3/2 for the m, and 1 for the b. So I'm going to have y equals negative 3/2 times x plus 1. And that would be the equation of the line that we see. Okay, let's take a look at example number 2. We want to write an equation here given the slope and a point that the line passes through. In this case, we are told that our slope is 2, and it passes through the point 2, 1. Now, we don't know the y-intercept in this problem, so we're going to have to use point-slope form instead. The x1, y1 is our point that's on the line. That's the point 2, 1. Our m is our slope, which it says is 2. So I'm going to begin by taking my point-slope form. Y minus y1 equals m times the quantity x minus x1. And I want to plug in the numbers in their correct places. So y minus y1. Now y1 is the y value of our point. That's a 1. The m, that's our slope, which if I go over here, that's a 2. And then we have parentheses, and then x minus x1. Now x1 is the x value of our point, which is also a 2, so I can put that in. Now, once I fill in the numbers in the right places, then I should put it back in slope-intercept form by getting the y all by itself. So we still have y minus 1 on the left side. On the right side, though, I can take my slope here and I can times it to both of these using distributive property. That'll be 2 times x minus 4 when I do that. And then the last thing I'm going to do to get the y by itself is I'm going to add 1 to each side. And so I end up with y equals 2x minus 3. So the equation of my line that goes through the point 2, 1 and has a slope of 2 is the line y equals 2x minus 3. All right, let's take a look at example 3. It says write equations of parallel or perpendicular lines. Now in this problem it says write an equation of a line that passes through a given point. My point is negative 1, 1 and is first of all parallel to this equation. And then secondly is perpendicular to this equation. So we're actually going to have two problems here. Now first of all, we know that lines that are parallel have the same slopes. So as I look at the equation that I'm comparing to here, y equals negative 2x plus 3, the given line has a slope of negative 2. That's the m. So a line that's parallel must also have a slope of negative 2. Now for perpendicular, remember, the slopes are opposite reciprocals. So to do the opposite reciprocal, it must be, we must have the opposite of, and then flip it over, so 1 over the original slope. So if my original slope is negative 2, then the opposite is positive 2, and if I flip that over, it actually becomes 1/2. And so we have our slope for our parallel line, which is negative 2. And we have our slope for our perpendicular line, which is 1/2. Now, the point the line goes through is the point negative 1, 1. So that's my x1 and my y1. So we want to remember all of those pieces here as we write the equations for our lines. Now, I need to scroll this down a little bit, but we want to remember what our slopes are and what that point is that it goes through. So as I scroll this down, keep in mind that my point is the point negative 1, 1, and then for letter A, if it's parallel, then it's the same slope, so it's negative 2. For letter B, it's perpendicular, so we said it's 1/2. So let's do A. So we want to write the equation of the line that's parallel. So I'm going to go y minus y1. Now the y1 is a 1, equals the slope, which would be negative 2, times x minus x1. Now that's negative 1. So we're going to have y minus 1 equals, that's the same as negative 2 times the quantity x plus 1, because when you minus a negative 1, it's plus 1. And so then if I was to use distributive property, I'm going to move over here a little bit because they don't give me enough room right here. So that's going to be y minus 1 equals, when I times the negative 2 to both of these, that's going to be negative 2x minus 2. And then to get the y by itself, I got to add 1 to each side. So I'm going to end up with y equals negative 2x minus 1. So there's the equation of the line that's parallel. Now let's do the perpendicular line. So again, we have y minus y1. Well, the y1 is 1, equals my slope. Well, it's 1/2 this time because it's a perpendicular line. And then we have x minus x1, which is a negative 1 again. And so again, let me move over here to the side where I have more room. So we have y minus 1 equals 1/2 times the quantity, and that's going to change to x plus 1 when you minus a negative 1. And then I got to times both of those by 1/2. So y minus 1 equals 1/2 x plus 1/2. And now I'm going to add 1 to both sides to get the y by itself. So y equals 1/2 times x plus, Now, a half plus 1 is the same as 1.5, or it's the same as 1.5. As a fraction, it's the same as 3 halves. And so any of those answers would work. I chose to write it as 3 halves. That's a simplified fraction. Generally speaking, that's how we try to write that. If you wrote it as 1.5 or 1.5, that would also be totally acceptable. Lastly, we're going to look at example 4. In this problem, we're going to write an equation of a line that goes through 2 points. Now the 2 points are the point 3, 1 and 2, negative 3. The first thing I need to do in this situation is I need to find the slope of these 2 points. So I'm going to go y2, that's negative 3, minus y1, which is 1, over x2, that's a 2, minus x1, which is a 3. And so that's negative 4 on the top, and that's negative 1 on the bottom, which gives me a slope of 4. So there's my slope. Now, since I have 2 points that the line goes through this time, I need to pick one of them. It doesn't matter which one you pick. I'm just going to pick the first one. They're both on the line, so it really makes no difference. So we're going to say y minus y1, well that's going to be y take away 1, equals m, which is a 4, times the quantity x minus x1. Well, that would be 3. So that's how I would plug the numbers in. And now what I have to do is put it in slope-intercept form for the final answer. So I'm going to move over here where I have some more room. So that's going to be y minus 1 equals, when you times both of these by the 4, you're going to get 4x minus 12. And then lastly, I got to add 1 to both sides. So I'm going to end up with y equals 4x minus 11. And that's the equation for the line that goes through those points. Now, if you had picked the other point, let's do that up here. So if I picked the other point, that would be y take away negative 3 equals my slope, which is 4, times x minus 2. Now initially they don't look the same, but that's the same as y plus 3 on the left side. Over here, when you times those by 4, you get 4x minus 8. And now, when I subtract 3 on each side, I end up with y equals 4x minus 11, which is exactly the same thing. So as you can see, it doesn't really matter which of the 2 points you pick to put in for the x1, y1.